have that much of I'll just type in Mercury. Try and switch off the background music, sound, music, fine. Okay. So we'll first start with Mercury, and there's an I button that we can just press, and we get all the information over here. So Mercury is the innermost planet in the solar system. It is also the smallest planet, and its orbit is the most eccentric. It orbits the sun once in about 88 days, completing 3 rotations about its axis for every 2 orbits. The planet is named after the Roman god Mercury, the messenger to the gods. Mercury's surface is heavily cratered, indicating that it has been geologically inactive for billions of years. Due to its near lack of an atmosphere to retain heat, Mercury's surface experiences the steepest temperatures gradient of all the planets, ranging from a very cold 100K 100 kelvins at night to a very hot 700 kelvins during the day. Okay, so there are a few details over here you can see. Yeah, the significant stable global magnet around. These are the physical properties: the diameter, the mass, the density, oblateness, effective temperature. Okay, and if we want to land over here, then there should be an option. Yep. So now this would basically land on the surface of the Mercury. So this is how it would look if you are on Mercury and if you're watching the sun from it, you know. So the sun still looks pretty far. I mean, I would imagine that it would be very near, very close by. And there is not much on the surface. Maybe I should increase the speed. Okay, now this is fine. Let's go to Venus. Let's check what we have in Venus. This is our little planet Earth. It's far away. You just type in Venus. Over here at the top, you can see the distance. The distance is 0.5 AU, astronomical units. So astronomical units, I guess 1 light year would be, I mean, 60,000 astronomical units would be 1 light year, 63,000 to be precise. So this is Venus. This is the hottest planet in the solar system because it has a thick cloud of gases, you know, that acts as an insulation, and it keeps the heat inside from, it doesn't allow the heat to escape. So you can see it is so cloudy. It is its atmosphere basically. I can disable the atmosphere from here, I guess. Yep. See, I disabled the atmosphere and now it is looking so less bulky. But it still has a lot of gas in it. And you know, there are various hypotheses that say that this planet was also once like Earth. I mean, it could have. Okay, so I disabled the cloud, and now this is how it looks. It's a rocky planet, of course. Okay, we land over here. Where's the land? Background music. Which music it is? Okay, what music it is? So this music is also off. Is there a glitch with the software? I mean, I switched off the music, sound effects maybe. I mean, I've switched off everything, even the music of the engine. Okay, so I think it should be fine now. So we are on the surface of Venus, and yeah, the atmosphere is not there, as well as the clouds and all. We can get them back. This is water, auroras. Okay, so see, now the clouds are there, the thick clouds you can see. You cannot see the space. and atmosphere is also enabled. I'll just take off from here. Yep. This almost looks like a sun now. I mean, it's glowing so much. Okay. This planet is very mysterious, in my opinion. It has a wonderful history, and even the present, there are a lot of volcanic activities that take place and lots of lavas and all flowing inside. Okay, now shall we move to Earth? I mean, we have seen Earth a million times to the images of satellites and all. We can just go if we want. We can have a quick visit. So we are traveling over here. The distance is reducing. Now it's a few thousands of kilometers. Here we are, the Earth, the blue planet. So did you notice anything? The Earth looks so different from other planets out there. It looks so blue. It has a decent amount of clouds, not acting as an insulator or like a sheet blanket to trap in heat. And it also has water, of course, greenery, vegetation. So see, let's reduce the speed and try and go inside a land area. Whoa, just have a look at the detailings. The clouds, we are passing through the clouds. Whoa, and we did pass. So my speed currently is 159 this 255 meters per second. Whoa. Increase the speed and I would just take off. But the software wouldn't allow me. Okay, it's allowing. So the atmosphere, will try disabling the clouds in the atmosphere. So the clouds are disabled. Okay, this is the sun. So it looks very familiar. What we see on Earth, it looks the same. The sun is very far away. I mean, comparatively to Mercury and Venus. Okay, so let's get off from here now. Wow. There's our Earth. Now let's move towards the red planet, Mars. A lot of people, I mean, a lot of scientists, they believe that we can, in future maybe, we can live on Mars. I mean, we can make it habitable. That process is actually called as terraformation. I mean, changing the planet, changing a non-habitable planet to a habitable planet. That is what terraformation is. So Mars is or may be capable of that. Once there is an atmosphere in Mars, there is a probability that there could be life that can sustain on Mars. The Mars is not looking red anymore. I don't know why. I think so it's receiving the direct sunlight. Wow. So you can see there are a lot of deserts over here as we have pictured. And the surface has a little bit of craters and depressions. What all? Let's have a quick information. So Mars is the fourth planet in the solar system and the outermost of the terrestrial rocky planets. It has a thin carbon dioxide atmosphere which has slowly been escaping to space for billions of years. So the Mars is depleting atmosphere and is too thin to significantly moderate the planet's climate. Enormous dust storms can grow to cover the entire world. The planet's moderate axial tilt and fairly eccentric orbit yields mild seasons in the north and extreme seasons in the south. So this is one of the most prominent features. There are extreme seasons because of the axial tilt. The Mars is tilted. Even Earth is tilted. It's 13.5 degree, I guess. That is why we have seasons, because of its tilt. The side that is closer to the sun, there we have the summer season, the hemisphere. and the hemisphere that is away from the sun, we have the winter season in that. That's why basically if there is summer season in the northern hemisphere, then it is exactly opposite in the southern hemisphere. If there is summer in southern hemisphere, in countries like Australia, New Zealand, uh, all those countries in the south, then there would be winter in the north, the European countries, North America, even in India. So Mars has extensive sheets of water, ice on and just below much of its surface. So it has extensive sheets of water and ice uh, just below much of the surface, and small amounts of liquid water may occasionally flow in some locations. So it has liquid water, small amounts. Mars shows evidence of having had a warmer and a wetter past in which water flowed across much of the surface for extended periods. Okay, so it has a past uh, in which it may be abundant in water at some point of time in the past. So some of these locations are good environments for life. It is not known whether such life existed. The surface today, though cold and dry, boasts some of the largest geological features in the solar system, including a 5,000-kilometer rift valley and canyon system and a 22-kilometer tall and 600-kilometer wide volcano. Is it the Mount Olympus Mons? I guess. Okay, these like numbers are for the geeks or the nerds. They're very technical numbers. 90. Ascending node, argument of pericenter, mean anomaly. Let's land on here and see the view. I mean, in future, if we would be living on Mars, we can have a view. I'll have to disable the atmosphere over here. One sec. Yep. Okay. Okay, so these are the orbits. I by mistake switched on the orbits. Let me close that down. So this is our Earth, this is the Sun and all the planets, and this is the view that we can expect from Mars. It doesn't look much red. Oops, this is a little glitch, I guess. This software is actually very good if you're trying to make a documentary on space and stuff. Even the video that I had made on Moon, on the birth of Moon, I had taken all the footages from this engine about the Moon and all. It is so realistic. So you can see all the craters and all. It looks so realistic, and just the view that you would expect. It has differences in colors as well. It doesn't have to be darkness, I guess. There is definitely a slight change in color. Maybe this area would be could be wetter. It could have traces of water or water elements in it. And this is like desert. This is a dense sand. It could be dense sandy area. Okay, let's move away from it. Okay, so now let's move on to Jupiter. So let's move on to Jupiter. So as we know it, that Jupiter is the largest planet in the solar system, but it is a gas giant, cold gas giant. You can see at the top left corner, cold gas giant, and this is the distance, these many astronomical units. This is Jupiter, the infamous planet in the solar system. There's actually a great spot on Jupiter. Yeah, here it is. This is very famous spot. This looks very small, but it is very large. I don't know the exact the area it covers, but it is a very large spot, and there's a violent storm basically that is spinning inside since years and years. This storm is brewing something inside, the Jupiter. It's not that clear in this engine, but basically this is a storm, the great spot. And then these are also a few storms that are going on because this is a gas giant. It also has a ring. It is not that as visible as Saturn. It also has one. Let's have a quick info about it. So Jupiter is the 5th planet from the Sun and the largest of the solar system, as well as the planet with most moons. Viewed from Earth, Jupiter can reach an apparent magnitude of nearly -3m. Okay, so this is some kind of figure, making it the 3rd brightest object in the night sky after the Moon and the Venus. Okay, so we had seen Venus, it was very bright. It has been considered a powerful deity for thousands of years in many mythologies due to its brightness, and modern day explorations are proving that these ideas were more accurate than otherwise might have been assumed. So in Hindu mythology, I guess it is called as Buddh, if I'm not wrong, and it is one of the deities. Saturn is Shani, I guess. Composition and atmosphere. As a gas giant, Jupiter has nothing that could be considered a surface. Its atmosphere simply transitions smoothly from gas to liquid to solid as it gets deeper. Okay, so the solid part would be its core. It's composed mostly of hydrogen and helium with only small amounts of other elements. Numerous storms exist on its surface at any one time, notably the Great Red Spot, the spot that we were talking about, an anticyclonic storm the size of the Earth. Whoa, it's the size of the Earth. There's a storm that is the size of the Earth, which has been active for at least 300 years. So it's wreaking havoc, all the rampant winds. Moon. Jupiter's first 4 moons were discovered by Galileo Galilei in 1610 and today are known as the Galilean moon in his honor. Of its total of 67 moons, so it has 67 moons. The Galilean moons are the largest and the most massive, making up 99.9997% of the total mass in orbits around Jupiter, and all except Europa are larger than Earth's moon. So Europa, there's also a mission going on, Europa Clipper mission, that we are actually planning. In 2019 there would be a spacecraft that would go to that moon, Europa, and we suspect, the NASA scientists, they suspect that there could be life beneath the frozen crust. So that is why they are going ahead with this mission, Europa Clipper. The remaining 63 moons are very small by comparison, barely more than asteroids. Okay, right? So remaining majority of the moons are like asteroids. They would be like 100 to 150 kilometers in diameter. The innermost Galilean moon, Io. Okay, Io is a moon that has a lot of volcanic activity in it. It's currently the only location in the solar system other than Earth to exhibit active volcanism. Okay. So that is what it was famous for. Second is Europa, the smallest of the Galilean moons, covered in a shell of thick ice and theorized to possess an ocean of liquid water underneath this ice sheet. That's what we talked about. Third and fourth are Ganymede and Callisto, respectively. Both are composed mostly of water ice and may also hold subsurface oceans like Europa. Now we'll jump to the rings. Like all gas giants in the solar system, Jupiter has rings. However, they are very tenuous and dark, being mostly composed of materials ejected from Io's volcanoes and the debris from meteoroids impact on various moons. So this is how the rings of the Jupiter has been created. The materials ejected out of Io's volcanoes and the debris from meteoroid impacts on various moons. So it has so many moons, and definitely there would be a lot of collisions and impacts. So all that material that gets trapped in that orbit because of massive gravity of Jupiter. So that is what we see as rings. Orbit. Jupiter occupies a typical circular orbit with a semi-major axis of 5.2 AU astronomical units, an inclination of 1/3, and a low eccentricity value of 0.04. Okay, so let's have a look of its orbit because it's a very big planet. We'll have a look of its orbit. I'm just zooming out. You can see so many moons are there. And see, most of the moons are very small, tiny, tiny. I'm traveling, so well, let it be. Let's check the orbit. Let's enable the orbit. Oh my God, there it is. For some reason, this menu is not popping out. Okay, so I just tried O and it showed up. So this is the orbit. The Jupiter, you can see it was so large when we are closer to it. Now it looks so tiny. And this is its entire, the orbit of its moon. You know, all the moons are revolving around Jupiter. And now when we compare it to the sun's orbit, you can imagine that is the sun. So far away is Jupiter. Let me increase the speed so that we can have a better view. See, this is the solar system basically. This is our sun. The Venus, you can see. Mercury, I guess it is obscured somewhere. Yeah, it is obscured by the sun's brightness. You cannot even see that. So Venus, Mars, Earth. This is Ceres. Jupiter, Saturn, which we'll be visiting now. So you can just imagine how large the sun is. It is like 99% mass of the entire solar system. Times bigger than Jupiter, times bigger than Earth, of course. So you guys know, I assume, that what gravity is and how sun is actually creating the gravity, because it has warped the space-time fabric. This is the space-time fabric. It has warped it. That means it has created a huge, you know, like sort of it downward tilt in that space-time fabric, a whole kind of stuff, not a hole exactly, but it has created a depression in the space-time fabric, and because of that, in that depression, all these planets are moving and they have a forward acceleration, because theories say that, you know, according to the laws of physics, whenever any object falls down, it would fall with an acceleration towards with a velocity, right? So if Saturn falls down because of the gravity, so Saturn would move right away here, and then it would go like this, and it would keep on moving. It would keep on moving for years and years, millennia and millennia, for millions and billions of years, because there is no external force that would be affecting it. So it would keep on moving and moving, and that is how these planets actually work. This is the sun. It's so bright because of the nuclear fusion reactions. So I have all these in the videos actually, and you guys have of course seen that. What is this? Okay, so now let's move to Saturn. Here it is. I'll have to reduce the speed. The problem with this is, I mean, like, you need to have an exact speed, because if you go at a speed which is much faster than these planets' proximity to each other, then you'll just pass them away. And if it is very slow, then it'll take minutes for you to reach there. So we are at a right speed now. Saturn also has a lot of moons. You can see Tethys, Enceladus, Mimas, Janus, Prometheus, Dione, Rhea. This is the Saturn, and the rings, the infamous rings, is actually because of the dust and the ice and, you know, all those kinds of stuffs. Even the debris that have accumulated because of the asteroid strikes on its moons. And Saturn actually has a very big ring. I mean, it's a very thick ring. The ring's thickness is somewhat like 20 or 25 kilometers. That's why it is so visible. And it is also a gas giant as we know it. So how is the view from Saturn? Whoa, the sun is so far away. Saturn is a cool place to be. I don't think so there would be much heat. Uh, the infrared, the ultraviolet rays also. There is light, of course, because light would be there, but there won't be heat much. Yeah, we can try and I don't know why this menu is not coming. I'll try and A. Okay. The thing with this is it also gets stuck, or there's a glitch in the system or something that it just hangs, or it just something, it just starts doing weird stuff. Okay, we can just try and put in information. Composition and climate. Saturn is the outer of Sol's two gas giants, massive worlds composed primarily of hydrogen and helium. It has no solid surface. Instead, it has a steadily thickening hydrogen-helium atmosphere, which eventually becomes liquid metallic hydrogen as depth increases. At the center of the planet, there is likely a solid rocky core. Of course, circulation in the liquid metallic hydrogen layer is the probable source of Saturn's magnetic field. Okay. So metallic hydrogen. Saturn's aurorae are the tallest in the solar system, reaching over 1,000 kilometers in height. So the auroras are basically the ones that you can see at the poles. Even Earth has auroras, the slightly greenish color stuff. Saturn's poles are ringed with huge rotation cloud structures. In particular, the North Pole is surrounded by a giant hexagonal structure, and the pole itself is the center of the powerful vortex. The South Pole has a warm polar vortex. Unique solar system temperatures in this vortex are over 60 degrees warmer than the rest of the planet, making it the warmest spot on Saturn. Elsewhere in its atmosphere can be found strong storms that can persist for months. One of the most spectacular storm features is the periodic Great White Spot, a massive storm that erupts about once every Saturnian year. Okay, these are its rings. Saturn's majestic rings are easily its most prominent feature. The rings are tens of thousands of kilometers wide, but average only 20 meters thick. Okay, it's meters. They are composed mainly of water, ice, and modest amounts of carbon. The particles in the rings range in from the size of dust grains to chunks of materials in tens of meters wide or more. The main ring disk has several gaps carved out of gravitational perturbations and by small moons orbiting around the rings. So 62 moons, it has 62 moons. And the famous one is Titan, I guess. Titan should be, yeah. The largest of these, Titan, comprises 90% of the mass orbiting solar Saturn and is the second largest moon in the solar system. Titan. Only moon with thick atmosphere and only known world other than Earth to have stable bodies of liquid on its surface. So it has liquid on its surface, we know that. Among Saturn's other large moons are Iapetus, Rhea, Dione, Tethys, Enceladus, and Mimas. All of these orbit near Saturn and its equatorial plane except for Iapetus. So this is how the everything, the environment looks around, the ambience looks around Saturn. Okay, let's move to the Saturn's the largest moon, which is Titan, where it is. Can you see it? So let's just type in Titan and then hit G. So there is liquid water in Titan. Let's see how Titan looks. This is the largest moon of Saturn. It is the 90% mass of all the bodies that are revolving around Saturn. So it is a large moon. It is the second largest moon in the solar system. I would have liked to, remove all these atmosphere and clouds and all, but I don't know. I'm not getting that feature.